Okay, now let's try to do this question. It's not, I want sine 3x. Let's try to do this question. Using tabular integration. All right, first, liate. Again, e is exponential and sine is trig, so this should be integrated because it's on the right. This should be differentiated because it's on the left. Let's make the table. Plus minus the integral. And then you have e to the 2x, we decided that this should be integrated. And sine 3x should be differentiated. Okay. And this is the case when this doesn't hit 0. Right? If you differentiate this cosine, and differentiating again, you get negative sine. It just flips between sines and cosines, so it never hits 0. Right? So for this case, you just have to memorize that for these types, you have to stop at the third row. So you differentiate once, that's 3 cosine 3x. You differentiate another time, that's negative 9 sine 3x, and you stop here. And then for this one, you integrate. This is 1/2 e to the 2x. Integrated again, it's 1/4 e to the 2x, because every time you integrate, 1/2 pops in front. Right? The first column, you put plus and minuses, starting with plus. Okay? So you always start with plus and you alternate. And once you're done with this table, once you've completed the table, you do this shooting missiles thing with sound effect. So it's negative 3/4 e to the 2x cosine 3x. Right? Negative 3. Okay. And then the last row has to be multiplied. So it's like a bullet going that way. And then it's negative 9/4 e to the 2x sine 3x. And I said that the last row has to be done what? You have to integrate the last row. So this result tells us the following. It says that this integral is equal to 1/2 e to the 2x sine 3x minus 3/4 e to the 2x cosine 3x, and then minus 9/4. I can pull the 9/4 outside, right? And e to the 2x sine 3x. So that's the result that we get using the tabular integration, which is equivalent to what we would get if we just did the integration by parts. So it's an equivalent method. It's just a different way of packaging the same exact thing. Okay? And then to finish this off, again, you still have to add this to the other side. So you get, since this is 1, you have to do 1 plus 9/4 e to the 2x, integral of e to the 2x sine 3x dx. And what's left here is, see, they both have e to the 2x as the common thing, so let's factor the e to the 2x out and get 1/2 sine 3x minus 3/4 cosine 3x. And then let's just multiply by 4 because I don't like fractions that much. So multiply by 4. So that 4 times 1 is 4, and 4 and 4 will cancel, giving you 13 for the first one, right? You get 13 times e to the 2x sine 3x dx. And when 4 is multiplied to each individual ones, you get e to the 2x 2 sine 3x minus 3 cosine 3x. And then finally, dividing by 13, you get your final answer, e to the 2x sine 3x dx equals 1/13 e to the 2x, 2 sine 3x minus 3 cosine 3x, and then you have to finish this question off by putting the cos c. Yeah. And that's equivalent to the answer that you will get if you did integration by parts twice. Now, if you compare this with what you would get with integration by parts, you do see that instead of having to do integration by parts twice, you just had to do a single tabular integration. So this is much faster and more convenient.